Hello, this is Graham Lee with Fuzzy Aliens, and what I want to talk about in this screencast is what I suppose you might call App Storegate. On today, which is the 7th of January, a lot of news outlets have been reporting that it's possible to take receipts from applications downloaded via the Mac App Store and copy them into other applications in order to uh, make the operating system believe that the other application has been paid for. Uh, this comes from receipt validation failures on the part of the third-party developers. But what I want to look at today is how code signing is used with the Mac App Store and with the apps you download through it. Code signing has been in macOS 10 since version 10.5 and is used in various parts of the operating system. And applications which are bought through the App Store are signed, and developers have to have signing identities that they use to before they're allowed to submit the application to Apple. They have to sign the application that they submit in order for Apple to believe that it is their application. Okay, so what I'm going to use is the free Twitter application. I'm sure that many of you who have already used Mac App Store have already seen this application and have been using it. It must have been downloaded a large number of times. So let's dive straight in and see how that application is signed, indeed, if it is. So we'll use the codesign command line tool, which is useful for both signing and checking the signatures of applications, Mac and iPhone applications. And we see that this is signed with the Apple app signing certificate, as one would expect for an application that comes from the store. Okay, that's fine, but surely if we modify this application, it should break the signature. Well, let's try that. Let's take a copy of the application first. So we'll use the ditto command to generate a copy of this application on the desktop. Okay, here it is. Here's my copy of Twitter. Now let's try changing something. Let's modify something in the info plist, which is the file that basically contains the manifest for the application and kind of describes it to the operating system. So it says here that it was written by Twitter. Well, let's change that. Let's say that a malicious monster wants to pass this application off as their own. So we've saved this modified version of the file, and that should mean that the application signature is no longer valid, because the way that these signatures work is that the certificate private key is used to generate this hash value, which should be a hash of all of the contents of the application, and then the operating system compares the contents on the disk with this hash that's embedded in the signature. Now, as I say, I claim to have changed this, so surely the signature should no longer be valid. And let's have a look. Yep, either the code or the signature has been modified. The operating system can't tell which. All it does know is that this thing is no longer the real Twitter application. But we haven't changed any. I haven't changed the receipt. Well, indeed, this is a free application, so I don't know whether they've actually implemented the receipt checking. But let's launch the application, and you'll see that it launches. It starts up, but it hasn't been able to log me into the Twitter service. The reason for that is that the code signature is used by the operating system, but it's not used for validating whether an App Store application is valid. That's up to the developer to do with the receipt validation code that they should be implementing. The keychain is one service that does use this signature, and the way that it uses it is to identify which applications have access control rights to which keychain items. So when I previously launched Twitter, I had to log in, and Twitter stored my password in the keychain, and the operating system, the keychain services, used this hash, this valid signature of the Twitter application, to identify Twitter the next time it asks for my password from the keychain. Now, because I've now changed this application up here, this doesn't have the valid signature, and therefore the application isn't allowed access to that part of the keychain. But what's quite interesting is that the way that the application has been signed has the kill flag. Now, what that is supposed to do is to say, if the application loses its signature state, then it shouldn't be allowed to run. The operating system should just terminate it. That clearly hasn't happened here. Now, whether this is a bug in the implementation, or that it's some expected behaviour and this is only a kill that happens in certain circumstances, is unclear. What is clear is that code signing is not an anti-piracy measure. It can't stop you from distributing an application and even changing it and passing it off as your own. It is just there to identify signed chunks of code, signed apps, to the operating system, and to give even more proof of this, should it be necessary, let me sign this broken Twitter application again with my own certificate. So remember, I've modified this application. It no longer matches the signature that's contained within it, but I'm allowed to re-sign it. And so if I now verify the thing again, we see that it now has a valid certificate again. It has a valid signature. It's signed with a certificate that isn't an App Store one, so the receipt validation check doesn't care about this, because it only checks the validity of the receipt. It doesn't look at who signed the application. Okay, so that's basically where code signing comes in, and I just wanted to show that it doesn't really play a part in any form of anti-piracy measure, in any form of content protection. It's just a method for identifying applications to the operating system kernel. Here's a link to my website at fuzzyaliens.com. I'll speak to you all soon. Take care.